This is Apollo Control at 211 hours, 21 minutes. We're about 1 minute now from regaining radio contact with Apollo 17 as it comes around the eastern limb of the moon on its 63rd revolution. Here in Mission Control, we've completed a shift handover. The flight director on this shift is Charles Lewis, and our spacecraft communicator is astronaut Gordon Fullerton. Flight Director Chuck Lewis has completed a status review with each of his flight controllers, and from all around the room, the reports of everything nominal come back. During this shift, two things of interest will be the firing of the explosive charges left on the lunar surface by the astronauts to assist scientists in determining subsurface structure. The first of these charges, designated charge number 6, is scheduled to be detonated at about 212 hours, 51 minutes. There is some latitude in this event, and because of that, we'll have the television camera on the lunar rover up early to catch the event at its earliest possible occurrence, which would be 212 hours, 21 minutes, and we'll leave it up through 213 hours, 21 minutes.
Yeah, just checking to see how the weather was doing there in Houston before you came in to work.
Oh, it's kind of a bunch of high clouds, cirrus, I guess, but it's down around 35, I'd say, and pretty windy, so it's nippy when you're outside.
Aha! And Houston, how's my biomed looking?
About 10 seconds to your pro there.
Okay, thank you.
America, we'd like the IR cover closed.
Oh, and away we go.
I think there might be a chance the sun will get in out there.
Okay.
Okay, Gordian, we're rolling.
Bravo, Polo, Gray.
Bravo.
Okay. Ron, your EKG looks good. The surgeon wondered how the irritation that you had mentioned because of the sensors is that getting any better?
Well, yeah, it gets better when you take them off and leave them off for a while, and I put the cream on it. And it looks like it lasts for about a day. You know, and every time I put it on at a different spot. And it takes about a day for it to get red and irritated.
And Gordo, for information, that's not unique. We're all having that, and taking them off is the best relief for it.
Okay. America, I've got some words about what you might use for crew optional photographs. Over.
Okay, yeah, let's write it down there. And why don't you write it on the back page or something like that, so we'll know where it is. Okay. Ready to copy.
Okay, magazine RR has no spare frames, so that if you want to take any photos, we're suggesting using the DAC and the 75mm lens, and using JJ, which is very high-speed black and white. 98% of JJ is unscheduled. Here's some settings you might use for Terminator photographs over Mari. Use T2.8, 1/500 and infinity. For Terminator over Highlands, use T4, 1/500 and infinity. And for Sokovsky on Rev 74, that's a GET of 232.58. That's sometime in the future here. We're suggesting using T5.6, 1/500 and infinity. Over.
Okay, Gordo, what was the f-stop for the Highland Terminator?
Okay, the Highlands Terminator would be T4. I guess that's the far side Terminator, and the near side Terminator is over Mari. That's the Mari setting.
Okay. Hello, Houston, America. Is today Friday down there?
America, Houston, I'm sorry. Say again, please.
Just wondering, Gordo, if today is Friday.
That's affirmative. It's Friday.
Okay, thank you.
Happens to be payday. It's the 15th. Jack, Houston, we see no need for you to wear any of your biomed sensors. If you'd rather take them off, give your skin a rest, feel free.
Okay, Gordy, I've done that, and I'll wait till my next time and put them on then.
Okay.
Yep. Gordy, how do you read LMP?
You're loud and clear, Jack.
For a relatively quiet period, let me make a few comments about some of the things that across the two big basins that we're getting very familiar with, are actually three: Smithy, Smithy, Crisium, and Serenitatis. And the degradation of the balls of the major ring, and the lack of any obvious blanket structures, I think, in contrast to Imbrian and Oriental, which we've also had a pretty good look at, Oriental and Earthshine on the early revs, is quite striking. That contrast is quite striking, to me at any rate. Also, within Oriental, at least at the on the east-southeast portions of the Mare floor, the wrinkle ridge system is not nearly as well developed, but there is a wrinkle ridge system that roughly forms an inner floor ring at any rate.
Roger.
The fronts of the major ring and Crisium are strikingly different than those of the Apennines, just in their general slopes, sharpness of topographical features. and in any appearance of having even a hint of boulder fields on their slopes, like we observed, say, on the South Massif, anything like that. At least Serenitatis massifs seem to locally show fairly major boulder fields on their flanks. And I haven't seen any around Christian yet. Maybe Ron's already talked to you about that, but I haven't seen any.
Okay.
Yeah, the craters. I'm speaking of the Ron, of the front faces themselves, the rim, the face of the ring itself.
Oh, I see. Yeah, the face of the ring itself.
Yeah.
Okay, that's what you're talking about. Yeah.
No, a crater, a fresh crater in the Mare or a fresh crater in the blanket area, rim area, will have boulders, Gordy. Don't misunderstand me. But the front faces, the ring front face, does not have boulders that I've seen. And I think boulders are pretty obvious when they're there. We've seen them well-defined on the central peaks of Tsiolkovsky, and I think anytime you have a major boulder field, you can see it with a monocular, with a 10-power monocular.
Roger.
Getting into areas that resemble in their surface texture the sculptured hills of the Taurus Littrow landing area. Here we're just passing, where are we? That would be, I got disoriented all of a sudden. Proclus is there. So it's in the ray excluded zone of Proclus, where there's a Mare surface projecting up into terrain that looks like sculptured hills. And that Mare has a distinct bluish gray color in contrast to the regolith associated with the sculptured hills, between the hills at least, which is brownie, let's call it a tannish gray. Quite a sharp color hue contrast to my eyes, at any rate.
Roger.
Okay, that was a projection of Fecunditatis Mare, I guess, up into there. Yeah. Sculptured hills tend to have both a regional distribution and a structurally controlled distribution. The structural control being apparently related to the rims of old craters. For example, there's some sculptured hills appearing topographic materials that again in the ray excluded zone, but out in Fecunditatis, define the rim of a fairly large flooded crater in Fecunditatis. And all of this may tie in with the possibility that we saw at the landing site that sculptured hills are composed of an igneous gabbroic rock, and these may represent local intrusions controlled by the structure of an old impact crater, extrusions controlled by the structure of the old impact crater.
Roger.
I've noticed now I'm getting a good view of where in Fecunditatis there is tannish, or let's call it more of a brownish gray moray in contrast to bluish gray moray in Facunditatis itself.
Roger.
And in the walls of some of a large crater, I'll try to figure out which one it is in a minute. It's near the large crater that the Sculptured Hills defined. You can see in the east wall, or maybe northeast wall of that crater, an area of bluish gray material that is streaking the normal tan gray of that crater wall.
Roger. This is kind of a one-sided discussion. I wish I was there so I could take a more active part.
That's all right. I just thought I'd fill in a few things. This isn't a good viewing attitude at all, and get a few isolated views that may be worth commenting on. The contrast in my eye, anyway, between the three color units around the landing site is let's call it a medium bluish gray to gray for the dark mantle, a light blue gray for the annulus around Serenitatis, and then a tan gray for the Serenitatis mare proper. And in Dawes, you can see, I think you can see that the overturned, or the rim materials are made up of the brownish gray material, and the walls underneath those rims are the bluish gray, which is the age relationship suggested by topography. That'd be the lower unit is forming the rim with inverted stratigraphy.
Roger.
The light blue-gray annulus is also the locus of most of the circumferential grabens that Serenitatis is noted for as in that area, and that's nothing new. But in one place there's a very subdued flooded crater which seems to control a arcuate projection, or let's say a circular projection of the light blue gray out over the tan gray mare. Most of the major wrinkle ridge system of Serenitatis, of course, is outside the annulus of blue-gray, except locally, in one of those places was in the to the west of the Taurus Littrow site. Although that wrinkle ridge system does, I can see now as we look south of in the southern portions of Serenitatis, that wrinkle ridge system does cross the contact between the blue-gray and the tan gray. That's the light blue-gray and the tan gray.
Okay.
Good impression I've had in looking at all the mare where the wrinkle ridge systems are developed is that they're a late feature. They, at least at low sun and sometimes even at high sun, they have a very, very sharply defined ridges with steep slopes on either side that seem that in general give me the impression that they're constructional possibly associated with some thrusting movement. In the vicinity of Sulpicius Gallus, there are several small craters that look like impact craters that, believe it or not, have, in my eye anyway, orange ejecta blankets.
Roger.
Yeah. Ron says that he already commented on those, and they look very very obvious to me. I don't know. I don't think you can with those ones. We'll get a good view of them again in one of the other attitudes. It's light orange, obviously not that it's in contrast to the brown gray of the dark mantle in the vicinity of Sulpicius Gallus. There's a good one right down there. Now that one looks like a constructional cone that's orangish. And that's right out on a raised projection of the brown-gray dark mantle out onto the light blue-gray annulus material. The southern and south western portion of Serenitatis has a general appearance of the sculptured hills, although the individual hills seem to be more widely spaced than around Taurus Littrow. Once again, historically, we're passing over the landing site of Apollo, or near the landing site of Apollo 15. Tell Dave Scott that the North Complex looks just as interesting as it ever did. It's going to remain with Emery Crater as one of the unknowns of the space program for a while, I guess.
Roger.
Hey, Gordo. I've been looking at the landing site off and on the last few routes, and I'd like to get, now that we've been there and back, your best guess of the exact position of what you think we landed. Because I think I've got it pinpointed pretty much so from here.
Okay, stand by one.
That question on the landing site location coming from Eugene Cernan.
This is one of the first opportunities that I've had to look closely at Archimedes, which is one of those craters that in the early days of the lunar mapping program helped establish some of the fundamental age relationships between the various units that were visible in the Earth-based photography. In this particular case, it related to the sequence of events that created Imbrium, cratered it, and then flooded it with Mare. And Archimedes is a completely circular closed circle as a crater, and it is filled with Mare. And it in itself is superimposed on the one of the main benches of the Imbrium crater. Now, to have Mare filling that crater and actually filling all depressions of approximately the same level in the vicinity of a large Mare region is one of the things that suggested to many people that rather than single sources for Mare lavas, you have a multitude of sources in a very fractured lunar crust. Ultimate source at depth, though, is still certainly a subject for controversy. The ridge and valley structure of the Archimedes impact blanket is not covered by Mare and extends to the southeast out onto the Imbrium bench. That was also one of the pieces of evidence used in those early days of photogeologic mapping of the moon. You'll have to excuse the reminiscing, Gordy.
Right.
And Houston, America, frame 150, 151, and 152 were taken of Sulpicius Gallus region of the 250 lands. 154 was taken to D Caldera, and that's magazine Oscar Oscar.
Okay, Ron.
This is Apollo Control at 212 hours, 2 minutes. And we've, within the last couple of minutes, had a report from the ALSEP officer here that we're seeing seismic activity on the seismic profiling experiment, which indicates that our first charge may have detonated early. Either that or a meteorite has struck within range to be recorded on the instrument. We'll be checking that. That first grenade, charge 6, which was a 1-pounder, was scheduled to have been detonated at 212 hours, 51 minutes. It does have a mechanical timer, and from past experience, we know that mechanical timer to have some variability. And when it opens the window, allowing a continuous firing command to get through and fire the charge.
Your vessel in Serenitatis that Ron and I were looking at last night, and I think he'd commented on being layers in the ledges that were visible in the walls, and I certainly concur with that. Although we could not trace individual layers from ledge to ledge within a coherent ledge, the layers were traceable, and in one case I'm sure I could count 6 or 7 ledges, layers within single ledges. it's any ledges that may have been present as a result of the Imbrium Mare have since disappeared by weathering. That's lunar weathering, of course. Of course, down here in the Imbrium, southern Imbrium, is one of the better regions of the moon to observe the wrinkle ridge systems, or Mare ridges, sometimes they're called. And it's purely that. They're fairly sharply defined, quite sharply defined ridges that are wrinkled in their pattern. Sinuous would be another term. And with sharply defined slopes on either side of the ridge. Sometimes they're flat top ridges, sometimes they're more like spines. And occasionally you see them that almost appear to have vertical slopes on one wall or the other. The whole impression that I have anyway is that there are maybe a combination of structure and folding of the surface of the Mare, construction on the surface and folding of that surface. It's particularly interesting that they tend to, wherever there has apparently been an old flooded crater. Yeah, did you want to get that stuff? They seem to be controlled by the shape of flooded old craters within the Imbrium Basin. And I think that's a safe conclusion because you get the standard outlines shown by the rills. The ridges, excuse me. Some of them are polygonal and some of them are quite circular. Ron, did you want to get these ridges, these rills south of Euler here? Okay, they're coming up.
America, Houston.
Go ahead.
Okay, I guess the last team promised you no changes to the flight plan, but they didn't say anything about changes to the changes, and I've got one. At 15 minutes from now, 2:12:20 in the flight plan. Might get that out, and I'll give you a change.
Just keep talking, Carl.
Okay, at 2:12:20, you're to stop the roll at 39 degrees and then do a verb 49 to 142, and we want to change the pitch to 268 and 0. That'd be 142, 268 and 0.
Okay, I got that change, and you want that about 18? 2:12:18?
I have to check back here. Yeah, I guess that's when it is.
Okay.
Also, as long as you get the book and a pencil, let me give you a few other one-liners.
Yeah, I'm ready to copy them.
Okay, let's see. The first one is at 2:14:55. And I want to add after that other stuff that's just above there, UV cover open and IR cover open.
Okay, at 2:14:55, you want UV and IR covers open.
Just turn the page at 2:15:37, 2:15:37. Change magazine November to Kilo Kilo.
Okay.
And the reason I'm so slow with an answer on that landing site position is, all I've got it in is latitude and longitude, and I assume that you want it in grid coordinates for your reference. One suggestion here was you tell us and then we'll confirm your guess. I just ran across another couple updates too, back to 213.15 in the flight plan. I give you the lunar sounder pads, the two of them on that page.
Okay, I'll get them. Go ahead.
Okay, T-start on the left-hand one there is 213-2010, and T-stop is 213-2420. Then the next one is T-start of 213-4140, and a T-stop of 213-5954. Over.
Okay, Gordo got them all. They're all at 213 hours. Start is 2010, stop 2420, start is 4140, and stop is 5954.
Okay, good read back.
And Gordo, I guess my best guess after looking down there from here is I've got the northeast chart of the Lunar Service Traverse outage in the command module. And about 84 point, correction, about 83.3. And about Delta November 0.5, or right on the top of the O and Poppy. Looks to me about like where we landed.
Okay, we got that.
And in thinking back about what my intentions were, that looks like probably a very reasonable suggestion. And the first thought I had about being close to Triton, I didn't think I was anywhere near that close. And of course, when you look out there and see a big hole, you don't know how big is big when you're down there. That big hole out there might very easily could have been Poppy out at 9 o'clock.
Okay, Gino, from science, we finally got it converted to your map coordinates, and their guess was close. Their best guess, with all the data considered, is 83.2 and DN.1, Delta November 0.1.
That might make sense.
That's pretty close to where the old CFD said it first right after landing, isn't it?
North of where we put these. Remember, that was a little ways away. That's the edge of the depression. It would move it a little.
Yeah, I'll buy that. That's in my scatter. And then that crater, as I looked out at 9 o'clock, that we landed next to was actually Poppy. Pretty sure of that large crater.
Okay.
And Houston, America, on MAG Yankee, use frames 31 through 35 at that last near-side terminator there.
Okay, Ron, I got that.
This is Apollo Control. There is some debate in the control center at this time as to whether or not that first explosive charge did in fact fire early, or whether the seismic profiling experiment was instead reacting to some natural phenomena, such as a meteorite impact or a moonquake. And we have brought up the television camera on the lunar rover early. We'll be looking at the area and attempting to draw some conclusions as to whether or not the charge did in fact go early, or whether it's still in place. Now that question could be answered quite neatly if the charge, of course, explodes on command as it's scheduled to at about 212 hours 51 minutes. And that first charge is a 1-pound explosive charge, about 1.1 kilometer from the lunar rover.
I'm just going to stop this maneuver this time around at 39 degrees.
Okay, Gene. Say, we got one question for Ron. We got large teams of engineers trying to locate the missing scissors, and we haven't asked you in a while whether you might have found them. It might save them a lot of effort down here.
Well, no, I haven't found them yet. And there's a lot of room underneath these CO2 absorbers I found out the other night because I lost my flashlight. But it kind of floated out, you know, and I saw it every once in a while. And we found the flashlight and got it back. But I still have a flashlight there where the scissors are.
Gordo, you might have someone hide them in a CMS and send a backup crew down to the Cape and see how long it takes them to find them.
Okay, I'll get an airplane scheduled up right away.
I just missed 39 degrees. I'll wait for it next time around.
By the way, Gordy, you working on next week's airplane schedule?
Yeah. What do you need? Need one from Hawaii back or something like that?
Yeah, you might have some 38s waiting for us in L.A. We can pick them up there.
Okay, but we'll have to work a three-way swap with some Skylab tips that'll be out there, and then Deke will meet you in Albuquerque halfway back, and I'll let you know how it all works out.
That sounds great. That sounds like easier than usual.
This is Apollo Control. We have a press briefing scheduled with the flight director from the previous shift, Neil Hutchinson, and that press briefing is scheduled to begin in about 5 minutes at 5:15 p.m. in the MSC News Center briefing room.
every commander has a right to change his mind. And Gordy, I'll watch the red apple.
Okay, Gino.
This is Apollo Control at 212 hours, 28 minutes. We're ready to switch to the MSC News Center briefing room now for the press conference, press briefing with Flight Director Neil Hutchinson. There is a possibility that during this briefing we'll have the detonation of the first seismic charge on the lunar surface. If that occurs, we'll interrupt the press briefing to announce the firing of that charge. We'll switch now to the MSC News Center and our press briefing.
Okay, Houston, we're starting to get to the margin on signal strength to get the data back. We want you to improve that by turning S-band mode, S-band normal mode voice switch to off center for about 5 minutes.
Say again?
Okay, Jack, we'd like you to turn the S-band normal mode voice switch to off center for about 5 minutes to improve our signal margin as you approach the LOS here.
Okay, off center for 5 minutes.
America, Houston, don't bother to answer, but we'd like H2, tank 2, fans off. That's hydrogen, tank 2, fans off. America, Houston, we'd like Omni Bravo. America, Houston, we'd like Omni Bravo. America, Houston, you can turn the voice back on now. Have about a minute and a half to LOS for a final goodbye.
Okay, this is America with a goodbye for this pass.
Okay, I guess the real reason for having you turn the voice switch off there is so the secretaries that are transcribing the air-to-ground here can catch up with Jack.
I don't believe it. Yes, I do. Okay, that's all you ever hear from me again.
This is Apollo Control at 212 hours 39 minutes. During our press briefing, we had loss of signal with the command module. Also, we did not have the detonation of the seismic charge. We have about 2 minutes of tape of conversation with the crew before loss of signal. We'll play that back at this time, and of course we'll interrupt if we should get the firing of the grenade. This is Apollo Control. We've just had the report from ALSEP that one of the bombs went off. We didn't see it on the television, but we are beginning to see some seismic activity. And we'll switch now on our television monitor to the seismic tracing. Let you look at that. No one here in the control center observed on the television the detonation of that charge. However, we are planning to replay the tape from that time and see if a close look at the tape shows any activity that we could see on the television camera. This is Apollo Control. It's going to take several minutes before we're ready to rerun the videotape of that time segment when the explosive charge detonated. In the meantime, we'll continue with our tape playback leading up to loss of signal with America on the 63rd revolution. That brings us up to date now with all of the air-to-ground that we had received from the crew up through loss of signal. We'll be reacquiring Apollo 17 in about 36 minutes. This is Apollo Control. The time at which we copied the firing of that first explosive charge was a ground elapsed time of 212 hours, 39 minutes, 44 seconds, which translates to 6:32:45 Central Standard Time, or rather 5:32:45 Central Standard Time. And we should be ready shortly to rerun the videotape from that segment of the television. And again, looking very closely, see if the charge explosion is visible on the TV. Charge was placed about 1.1 kilometers from the lunar rover, and it was the 1-pound charge. This is Apollo Control at 212 hours 56 minutes. We've had some unexpected activity on the lunar seismic experiment, and the ALSEP controller reports that there's a lot of activity in the ALSEP room, looking at the very active seismic tracings that we're getting right now, and some feeling that this may in fact represent the detonation of that grenade rather than the previous signal that we recorded. If in fact that is the case, we've missed it on the television because the television camera was pointed at another area at the time that activity began. And as soon as we have a further report from ALSEP, we'll pass that along to you. This is Apollo Control. We've had no further word from the ALSEP control area as to which of the two seismic events we've registered at the Apollo 17 site represents the firing of the first charge. However, it is noted that the second event came much closer to the nominal charge firing time. This is Apollo Control. We've concluded here in the control center that the second seismic event registered on the lunar seismic profiling experiment was in fact the 1-pound explosive charge going off. That occurred at 212 hours, 55 minutes, 35 seconds, which was about 4.5 minutes later than the nominal or T0 time. There will be a second charge fired. It is scheduled for 215 hours, 27 minutes. That will be a 1/2 pound charge, and it's located 0.6 of a kilometer from the lunar roving vehicle. We're now some 14 minutes from reacquiring Apollo 17 in its 64th revolution of the moon. This is Apollo Control, Houston. is Apollo Control at 213 hours, 20 minutes. We're standing by now to reacquire Apollo 17 in its 64th revolution of the moon. And we expect this, at least from the crew work point of view, to be a relatively quiet period. During this revolution, they're scheduled to begin their eat period. And they'll be operating some of the scientific instruments in the Scientific Instrument Module Bay, the SIM Bay, but relatively little scheduled in the flight plan during this period of time. We show the spacecraft in an orbit of 65.3 nautical miles at its high point and a low point, or parasynthion, of 62.4 nautical miles. And we should have acquisition of signal any second now. And we've had acquisition of signal. It'll take a second before we get good solid lockup.
Yeah. That's right. A lot of those with the flat floor has got to be a lava type thing down there.
And we've got a good solid signal now from the spacecraft, good data. And you're hearing Ron Evans in the background. Ron apparently has his mic in the so-called Vox mode, where it's triggered by his voice.
Houston, America.
Roger, America. Hello once again. You got about 1 minute to T-stop.
Okay, we're right with you, Gordon.
Okay. T-stop in it is 2420? Stand by, okay. Okay, we're coming up on 2420. The visual of Tsiolkovsky is hopefully pretty much recorded on the recorder.
Roger.
Market, stand by. Centers is standby. I guess a somewhat a small summary anyhow of the visual of Tsiolkovsky, concentrating primarily on the flow up in the northeast corner. To me, that particular piece that's fallen down in the crater there, and it's on one of the pictures, Tsiolkovsky 4 of 5. The piece that is down in the crater is on the right-hand side of the page. though it's somewhat of a molten state, it looks like it is a landslide that has slid down the wall of the crater and detached from the the molten state of material, rough-looking material that's on the rim of the crater, Tsiolkovsky.
Roger, Ron.
There seems to be high lava marks around the western and northern sides of the central peak. For some reason, it's not evident or visible on the south side of the central peak.
Okay.
Also, there seems to be the high lava marks on the raised portion of the floor in the contact between the dark material of the floor and the lighter, rough-looking floor on the northern side of the crater. In the first observation of the mass of material that goes out into the crater Fermi, it looks like there's a whole bunch of craters in there that are essentially rimless craters. However, on close examination with the binocs, I couldn't see any that didn't have at least a slight indication of a rim. The rims that were on them were essentially very subdued. They extended out to about a half a crater diameter. And these are on the craters in the 500 to 1,000 meter size. I didn't get a chance to look at it, looking straight down at the craters to see if there was any depressions or any domes or any type of a structure in the bottom of the craters. But I get the impression that they're primarily all look just with cones with no flat bottoms at all. And I'll look again at those things when we go by the next time. The flow that goes down into Waterman if we look at the picture Tsiolkovsky 5 of 5, the shadow is just about in the same area on this one as it is on that one. I didn't take a chance to look at that until I got to the west of it. So I had to look when I'm passing it from the north side of Tsiolkovsky looking south to see what's down in the shadow area there. But when you're on the west looking back across it, you can't see into the shadow. But the material that's in the floor of the crater Waterman is the same type of material that the little flow in the northeast corner has broken off and slid down into its own little crater.
Okay, roger that.
So I guess what I'm saying is that essentially whatever molten material that's up around on the rim of the crater Tsiolkovsky has been, well, I want to say extruded, not extruded, but pushed out, I guess, away from the crater and has been in a semi-liquid or semi-molten state in its period of deposition. I'll reserve judgment on some of the flat-floored or flat Amari-filled depressions that are around the crater until I get a chance to look at those the next time around.
Okay.
Say, Gordy, something that struck me, something maybe everyone else has thought about, but I hadn't before. Southeast corner of Smithy, there was a relatively large, or several large, somewhat subdued craters, but with relatively steep sides to them. And next to this one was a very small, white, bright haloed crater. And I watched the rays of this crater, and the southeastern rays draped over the slopes of this much larger subdued crater, draped over the walls, all the way down onto the floor. And as they draped over the walls, they obviously gave me a very good albedo change from the darker wall to the very much lighter colored. But as they hit the floor of the crater, they form patterns that are not only not unlike, but actually very, very similar to the light mantled area that we had been referring to as a possible slide back at Torres Littrow. The patterns as they drape down the inner slopes of the crater and onto the floor, I would be willing to bet if we went down there, we'd probably find the same type of thing we found at Torres Littrow. By that, I mean albedo changes that we can see here versus what we can see down there.
Roger, very interesting.
I look for these type of ray patterns where the rays just went out on a more horizontal plane. You can find them if you look hard, but as they drape over the slopes and onto the more level floor, they're very obviously alike.
Roger.
Hey, Houston?
Go ahead.
Okay. That crater, if you look at Smithy 101, and the crater's right by this, right above the Rev 62 there, you can see a bright spot on the north-west portion of there, and that's the breach zone of that particular crater. The thing that's intriguing about that to me is that if you look at the inner ring, it's a gradual slope from the center of the center of the crater is lower than the secondary ring around the thing.
Well, let me interrupt.
The center of the crater is
say
low.
again
You have
which
a gradual
crater you're looking at again in Smithy.
Okay, in Smithy, and Maury Smithy, 1 of 1. That picture.
Roger, I
And
have
right above where it says Rev 62. Okay.
Okay, gotcha.
Now there's two rings in there are two rings in that picture. Okay, in the inner ring, the central portion of that thing is lower and slopes outward, radially outward to the first ring, and then it drops off. In other words, it's a gradual slope, maybe somewhere in the 15 to 20 degree slope upward to the first ring. And then it's a steep slope on the outside of the ring at about 45 degrees, dropping down into the annulus.
Okay.
Yeah, color with 250 lens. Yeah, all along. I just took it today, 2 of them, 3 of them. Yeah. 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 I took 3 of them the last rev.
Gordy, CLMP, well, we're waiting for the site to come up again here, which seems to interest us every time we go over it. I think we sort of came to a general consensus on the problem of the smaller cone-shaped craters on the far side that have the little pool-like concentrations of material in the bottom. If you look at the freshest of those craters, that seems to be contiguous with the streaks of very dark material that cover the walls and the rim of the fresh cone-shaped craters. As the crater gets older, that material, that distinction becomes less obvious. However, the pool remains, and all you lose is the dark streaks on the rim and on the walls of the crater. I think we sort of suspect that pool in the bottom of the fresh craters is just the concentrated impact melt, some of which was stayed there during the impact, and other which drained back. That's what that drained back after the impact from the wall, drained from the walls, and then with time that pool may be subdued some. The structures in it, the swirls and little domes in that pool, are subdued possibly not only by the impact but by debris slides and avalanches off the walls of the crater.
Okay,
it seems to be a fairly consistent pattern when you start piecing several of them together.
Roger.
Black streaking on the walls and the blankets, Ron may have already told you, but it is characteristic only of the very freshest of those cone-shaped craters, and our pool craters, whichever you want to call them. And it seems to be very logical that it just represents a thin veneer on the rim and the walls of the impact-generated glass, and it's darkest presumably where it's quenched, and the pool itself is somewhat lighter gray than the black streaks and mantles.
Roger.
Jack, I get the impression of these bright ones. See that bright one right down in front of us there? If you look at those with the binocs or with the, I get the impression of a dark greenish black or blackish green. In other words, I get a green. Green cast. Green cast to the rocks. To the big blocks, you know, they're laying around there, around the crater, and also the ones that are down at the bottom. A greenish cast to them. Yeah, it is, isn't it? I can see that with the naked eye. That's a bright one. Where is the crater, though? Oh, that's Yerkes and okay. You're in box.
Hey, Gordy, we got another orange rim crater, and we'll spot it. I think everybody agrees. And this one very clearly looks like an impact crater that has its, let's see, we decided you're looking north.
Yeah.
Roger.
Yeah, it's north, east and west quadrants
Here, let me describe it. It's Yerkes, and then
Hey,
you have a 20
you have a key start time
kilometer
coming up here
crater,
shortly on
and
the
then a bright
sounder.
crater. Okay.
About 10 seconds.
Quit interrupting.
Okay, we'll get it.
What time is it?
We'll hack it up here, Gordy.
For 41.
Thanks, Gordy. Okay.
Saunders, operate.
That was close.
That was a very good call.
Thank you.
No sweat.
Hey, get a
At any
map.
rate, in the
Northeast and west quadrants of that little crater, and we'll spot it for you on the map, is a very clearly an orange pattern, an orange color to the ejecta. The other quadrant is lighter color, light gray.
Okay.
If I had a map, let's see, what did I do with my map? I mean, I've got a picture of that, I think.
right here.
No, go ahead. I can't see the line of sight anyhow, I don't think.
Gordy, my impression from Shorty the other day, and also from seeing these craters that seem to have orange that are around them that are look very much like impact craters from orbit at any rate. It may be that if that is an alteration phenomena, that it's being localized around the structure created by the impact. But in this latter case, it looks as if the impact itself penetrated into a zone of that color.
Okay, Jack.
Yep. Are you going to use your... There, look, take a look at it. And, okay. Doesn't show up that way today. Here. Color. I know. That's the spot. Yeah. Can't see it anymore. Yeah, these are good. This is a good view. They're between Taquet and Melanese, aren't they? Yeah, I see them in there now. Okay. Yeah, a little bitty ones. They're about a little bit bigger than the Shorty. Yeah, those are the ones that I called the other day. It was a very, very light tan. Guess you could put an orange tint to them.
Gordy, to put orange into perspective, at least as far as the LFP's eyes are concerned, from orbit, I would say that it's an orange gray. It's still a gray with an orange hue to it. And when I use any blue or tan or anything, it's a hue on gray, and I'll usually try to say gray in there, but to say something's orange, I think would be misleading. It's really an orange gray, but it's clearly a distinct hue.
Okay, kind of like dirty beach sand with a little orange in it, huh?
Well, we can't use that term anymore. That's copyrighted.
Roger.
Yeah, that's right, there is. That's the one, that's the area where I was trying to talk about. That's just north of, that's Sulpicius Gallus. No, that's a gouge, just, northwest of Sulpicius Gallus crater. Well, yeah, but I didn't talk about that thing. That's it. I was talking about the little orange crater. Now you can see all the colors down.
Hey, Ron,
down the gouge
spot
itself.
this one on the map too, Gordy. But there's a large gouge just south of the Sulpicius Gallus ridge. The gouge, it's a rimless depression, and streaming down from the upper portion of that depression are not only our Orophyrid and the orange grays, but some that would be a red-brown gray. Very, very clear coloration in this light. I think, my goodness, there's another crater we'll have to look at.
Yeah, there's a whole bunch of
that has something in the wall of it.
in that area.
Yeah, it's starting to... Man, we're seeing an orange moon now. Now this whole dark mantle in here around Sulpicius Gallus, they're scattered craters with a variety of orange to red-brown hues, and they all, except for that large rimless depression, which looked as if it was exposing some layers, which were streaming that color debris down its walls. All the other craters seem to be small impacts that apparently are penetrating just far enough into the dark mantle material to tap this zone of orange to red-brown material.
And just north of that elongate depression there is another circular crater, and it also was penetrating down through this mantle of stuff, and it had the reds and the browns and the oranges dipping down it too.
Hey, Gordy, just so you're fully aware, we're not sort of just leaning and getting colorblind up here. I'll tell you, this last one Jack was talking about was not even subtle. Its entire ray pattern was this same color material, and definite contact between it and the dark material around it. And it had that orange-brown hue to it without any question at all.
Okay, very interesting.
It really is. I saw that dirt day before yesterday at Littrow, but and I really haven't seen too much from orbit that I'd call really very distinct in color until this one. But boy, there's no question about this one.
Roger.
And we will pick up the lunar sounder.
Get a level and give you a little more warning, too.
I want to get a. I think it's right in that. Where do you got it? Let me see. Now, here's Sulpicius Gallus. No, you're up too far. You're up too far. It's closer to Sulpicius Gallus. Right in that ridge basin, right in there on a red line. Yeah. We'll get a picture of it today. Yeah. Well, it's all. Yeah. Okay. Sorry, Houston, turned that one off at a minute early.
Okay.
We'll pick up an extra minute on the next one.
Roger.
Okay, Houston, recorder's going off.
Okay.
Hey, Gordon, I better make this note now. What Jack and Ron were talking about apparently was an elongated depression. I was talking about in the same area, and I've tried to mark it approximately on the chart. But it was a classic, small, bright haloed crater. The classic, with the classic ejecta and everything. Except it was this orange hued crater. It was not bright white, but it was very classic. And as I said earlier, not subtle at all.
Roger, Gene. America, Houston, I have a TEI for Rev 72 to add, no hurry, maybe you want to wait till sunset.
Yeah, we'll wait till sunset, okay?
Okay.
Houston 160 and 162. Mag Oscar Oscar. We're taking from the north, viewing the central peaks of Copernicus.
Okay, Ron.
It's a long ways away. I don't know if it'll show up or not. It might.
Houston, it's America.
Go ahead.
Okay, Gordo, I'm looking ahead. I've been trying to stay ahead and see what's happening today and tomorrow on the flight plan. And although this has come up in the past, we haven't said anything about it. Ron put his biomet harness on a couple hours ago, and he's going to end up wearing it a total of 6 hours. Then all of a sudden we make a changeover again, and I put it on. And for a 12-hour period, and then we change again. And one of the problems up here is putting these things on, and you'd like not to leave them on too long, but once you get them on, you like to make use of them. And it's a problem, it's time-consuming. I'd like you to consider down there letting Ron wear those until tomorrow morning, having me change over then. And when EVA time comes, we'll take special consideration to whatever requirements there are.
You just got a thumbs up on that from the surgeon.
Okay, very Very good. Thank you.
Okay, Houston, just took whatever the three were before 39 on Mag Yankee of Euler, Tobias Meyer, Terminator stuff.
Okay, Ron, and for Jack, the surgeon says he's getting occasional erratic trace from Jack's biomed. He'll be happy if Jack wants to take a clear off.
Gordy, I don't know how to tell you this, but I haven't had my biomed on for about 6 hours.
Okay.
As a matter of fact, I haven't even had the sensors on.
Well, we must be copying the heartbeat of the America or something then.
How does it look? Maybe we ought to use it instead of mine.
America's ticker is doing fine. Along with everything else.
Okay, Houston, it's America. I've got a flight plan change for you if you're ready to copy.
Okay, ready to copy.
Okay, if you'll turn to page 3-26 at 2:17:52.
Okay, go ahead.
You can delete both those steps.
Okay, we got that.
Okay, if you'll turn to 2:30:40. You can cross out LMP and put CDR.
Okay, we got that.
Okay, if you'll turn to 2:30:29.
Okay.
You can change the first line, cross out LMP and put CDR. And on the second line, you can cross out CDR and put CMP.
Okay, I must be on the wrong page. Did you say 2:30:29? Must be 2:31:29. Okay, gotcha.
2:31:29. Cross out the LMP and put CDR in the first line, cross out CDR and put CMP.
All right.
Okay, and we'll further update you as the mission progresses. I know you're pretty busy, and we'll hold any flight plan updates down to you to a minimum from here.
Okay.
Okay, Gordy, you want to give me a TEI pad?
There's nothing I'd rather do. You ready to copy?
Go ahead.
Okay, it's TEI for 72, SPS/GNN. 36477 plus 061 plus 083. Now 33 is 23042 59er17. Now 81 plus 28874 minus 03394 minus 00503 179er 095 356. Rest of the pads NA, GDC Stars, Sirius, and Rigel. 136 160 034. All ages 4 jets, 12 seconds. Remarks, assumes ascent refs mat. Over.
Okay, TEI 72, SPS GNN 36477 plus 061 plus 083 230 425917 plus 28874 minus 03394 minus 00503 179 095 356. Sirius and Rigel 136 160 034. All ages 4 jets for 12 seconds. And it assumes an acid rest mat. Over.
Okay, that's good readback. So I have a little summary of how both the surface and the orbital scientific equipment's working. It's probably about 5 minutes worth. If there's some handy time, I'll be glad to read it to you.
Right now, Gordy, we'd love to hear it.
Okay, let me start with the Americas gear there. On the UV spectrometer, well, actually having to do with UV, back during Rev 38, they sent an Aero B sounding rocket from White Sands up, and it carried a UV spectrometer above the atmosphere and successfully acquired solar UV calibration data. Farside Terminator shows there is a hydrogen atmosphere, but it is much less than had been predicted. The PI is very happy with the Mode 4 maneuver. On the IR scanning radiometer, it's still performing beautifully, and the PI is getting lots of high-quality data, and I understand is ecstatic about it. On Rev 33, the crater Kepler-C showed up as a 132-degree Kelvin anomaly on a 94-degree Kelvin background after 11.6 days of lunar night. The crater Reiner was a similar anomaly on that revolution. In low orbit on Rev 9, Kepler-A showed a broad hotspot corresponding to its ejecta blanket with a sharp spike corresponding to the crater in the center. One cold spot anomaly seems to correspond to a cinder cone-like feature in Mare Orientale near the crater Hohmann. On the lunar sounder, telemetry monitoring of the sounder's average reflected power indicates that the Mare and Highlands exhibit markedly different reflectivity, both HF and VHF. The data is consistent with distinct layerings in the Mare, as would be expected, where the Mare flooded by successive layers of lava, although they say other explanations are possible. they don't see that layering indication in the highlands. Predicted topographic signatures over features such as craters and mare ridges have been confirmed in principle. Of course, as you know, until they get the film back, they can't really reach any definite conclusions. On the cameras, both cameras and the laser altimeter all appear to be performing very well. And everybody's especially happy with the solid laser altimeter performance. Okay, that kind of sums up the SimBay. Do you have any questions that I could chase down, or should I go on with the surface stuff?
No, why don't you press on?
Yeah, that sounds good, Gordo. Press on.
Okay, on the surface, the heat flow. These are little short summaries, each written by the PIs or COIs on each experiment. Mark reports the entire heat flow system is working perfectly. The probes have cooled down to a temperature of minus 16 degrees centigrade at a depth of 2.3 meters and are nearly at their final temperature. For comparison, at Headley Rill, we found a minus 20 degree centigrade at 1.5 meters depth. We had, to refresh your memory, was minus 16 at 2.3. Both probes show an increase of temperature with depth, and it is clear that we will get a valid heat flow measurement. The LEAM is functioning properly, responding to calibration, and the sensors show a low noise figure. The LEAM will be off until lunar afternoon and on with sensors covered until after sunset. Otto Berg asks that you accept his thanks and appreciation. On the LSG, the sensor beam cannot be null at this time, in spite of Jack's efforts. We are still studying the problem and hope to find a workaround. In any case, the instrument does function to some extent as a vertical seismometer and may be useful in a search for gravitational radiation from pulsars. The LSPE is fully operational. LEM-S and clearly recorded on all 4 geophones. And apparent seismic velocity measured across the geophone array was 110 meters per second. Regolith velocity was very close to that measured at the Apollo 16 site. The LEM impact was clearly recorded on the geophones, and the estimated distance was 10 kilometers away in the South Massif, actually very close to the targeted point. Although I guess you've discussed this, we didn't see it on the video. The first charge went off while you were on the backside last rev, and it's very apparent on the traces, which I'm monitoring right now. I think the next one's due sometime within the next 2 hours. Okay, the lunar mass spectrometer, the low voltage circuits of the LMS have been operated briefly. All monitors indicate the proper performance of the instrument, but application of high voltages will await lunar sunset when both the analyzer and the site have had time to outgas. Temperature of the radiator plate is slightly above nominal, but not so high as to be even important. That was from Dick Hodges. Okay, here's a little summary from Dave Strangway on the SEP. He starts out by saying, water, water everywhere, and plenty to be found because you didn't get behind the timeline. The SEP transmitter was confirmed to be working well at the correct power level using the lunar sounder. The receiver heated well above predictions during the whole mission, as I'm sure you're aware, but the 2 prime data legs were operated within the temperature limits of the recorder, and we have no reason to doubt that we got good data. There's also a good chance that the leg from Station 4 to the LEM was within the temperature limits. Your procedures were performed excellently, and we look forward to processing the DSE-8 tape. Okay, now to, let's see, we got the TGE, which is considered a spectacular success. The Earth-Moon gravity transfer indicates a value of, I won't read the number, milligals at the Taurus-Littrow base, but the value will be used to obtain a revised value for the lunar radius at this landing site. Gravity measurement made during the 3 EVA showed a large negative anomaly of about minus 38 milligals at the base of the South Massif, and a similar negative anomaly of about minus 30 at the base of the North Massif. Preliminary conclusions of the transverse gravimetry, the TGE measurements, indicate that the material under the valley floor of Taurus-Littrow is much denser than that of the North and South Massif. The gravity values will support the hypothesis that the valley subfloor consists of dense basaltic rock, perhaps as much as 3 or 4 kilometers in thickness. The extra measurement between stations 2 and 3 will be of great help in determining the nature of the boundaries of this basaltic layer and the buried extension of the massif. The cosmic ray detector, actually, you know as much as we do about the data return from it, of course, but we did recover it early in EVA3, as you remember, and that was due to a minor increase in low-energy solar protons and heavier particles detected here. And the reduced exposure will not offset the scientific result. The neutron probe was exposed to the surface for 49 hours. PI estimates that the distance from the RTG to the probe is 40 meters, which will mean that the background count will be low, and he thanks you kindly for those few extra steps. And the last one was, to be summarized, was the field geology. And they asked for a very short summary, so Waldberger came through with 3 typewritten pages. So we're just going to skip the whole thing except the last line, which was to say that you guys did an outstanding job. Over.
Thank you, Gordy. We're just pleased that so many of things are working well, and happy that the PIs are satisfied. That was our objective, and we came up here to meet it, and those things that are done, I hope we met it well, and we've got a few more things to do yet.
Well, I can assure you, you're not the only ones who are pleased.
Gordy? Gordy, well, you know, it's satisfying to have put that much time in and come out with some meaningful results. That makes us all feel good. Have you been able, or did you see that first charge on a video?
I forgot to mention that. No, we sure didn't see a thing. We had the camera aimed over there, but it was almost a kilometer away, and that was a 1-pound charge. And we played it back several times, but nobody saw a hint of anything.
Okay. And you got a few more going off here in short order, don't you?
That's affirmative. I don't think we're up to the next one yet, but we'll keep you posted on whether we see anything or how they're doing.
I might also say that we appreciate the time and effort the PIs put in with their experiments and with us also.
Okay, I'll make sure that gets to the back room.
Gordy, this is Jack. What they see over next to the sculptured hills on the gravimeter?
Well, let's see, Jack. It kind of... Let me turn back here. They actually included when they mentioned the negative anomaly of minus 30 milligals at the base of the North Massif, they said stations 6 and 8, parenthetically there. So evidently they're including the whole area there as the negative anomaly. I'll try to get a more amplified answer to your question.
Yeah, could you see if you can verify with them that they were unable to, or there was no distinction between the measurements at the Sculptured Hills and the North Massif?
Yeah, I'll work on that.
Or better yet, what was the distinction between the Sculptured Hills and the subfloor area?
Okay. You may have to wait till next time around for your answer.
Oh, there's no hurry. You can wait till tomorrow or even a week if you want to. I just thinking about that problem.
Okay.
By the way, Gordy, you might tell Bob Walker, if he's around, that the cosmic ray, as far as I know, was untouched by human hands, at least on the moon, and it looked very, very clean when I put it in put it back together.
Okay, Jack, we'll pass that along. America, Houston, one more question from the surgeon on this mysterious trace on the LMP's biomed. Do you have anything plugged in to the, is the biomed still plugged in and laying over on Jack's umbilical, or is there anything plugged in to Jack's that could explain the funny trace here? It's kind of a sporadic looking, looks like somebody with a heart in pretty bad shape. Over.
Gordy, my heart has always been in bad shape for other reasons than the one the surgeon's thinking about. It turns out that I am still plugged together. I just don't have the sensors on. I will remedy that situation so he doesn't have to worry anymore.
Okay, that solves the mystery. Thank you. Hey, America, about 30 seconds to LOS. See you next time.
Okay, Gordy, thank you very much. We'll see you coming around.
Okay.
This is Apollo Control at 214 hours 36 minutes. And we've had loss of signal now with America on the 64th revolution of the moon, be reacquiring in a little less than 45 minutes. And coming up at about 215 hours 27 minutes, a little less than 1 hour from now, we're scheduled to have the second detonation of an explosive charge on the lunar surface as part of the lunar seismic profiling experiment. This charge will be a 1/2 pound charge located about 0.6 of a kilometer from the lunar roving vehicle. The summary of science information read up to the crew by Capcom Gordon Fullerton will be available in the news center. We hope to get copies of the information read up to the crew to the news center and reproduced and available. It will, of course, also be available on the transcript somewhat later. At 214 hours 37 minutes, this is Apollo Control, Houston. This is Apollo Control at 214 hours 56 minutes. In about 1 minute, we'll be commanding the television on the lunar roving vehicle on, and we'll have it positioned to look for this second explosive charge, which is going to be fired at about 215 hours 27 minutes. This charge is part of the lunar seismic profiling experiment. It is a 1/2 pound charge of explosives located about 0.6 of a kilometer southeast of the lunar roving vehicle. And we've got black and white TV now from the lunar surface, and we'll have that through the converter and up on the area where that charge is located. And the instrumentation communications engineer will be putting that camera in the proper position. We're about 27 minutes away from the predicted time of detonation. However, we are within the window during which the charge could explode. As we mentioned on the previous charge, this window is brought about by the fact that the timer is a mechanical timer. The firing charge is sent continuously during the window, and as the timer moves across the face of the firing pin, the firing charge going in, or the firing command going in continuously, fires the charge as the window moves across the pin. And we believe the television camera is now centered on the area where this charge is located. Hopefully the charge is right in the middle of the television screen. We now have a clock configured here in the control center counting down to what our best estimate is for detonation of the seismic charge. And our T0 time is about 20 minutes away, 20 minutes 17 seconds to be exact. This is the clock that's designated H/O on the video monitors. is Apollo Control. We're now about 1 minute 20 seconds away from reacquiring Apollo 17. It'll be on the 65th revolution. And we're looking through the lunar rover television camera at the spot on the moon where we believe the second of two seismic charges to be detonated is located. We do have a problem with the TV camera in that it appears to be heating up close to the acceptable limit, and it could become necessary to shut the camera down prior to the time that we have the detonation. This decision will be based in part on what sort of priorities the scientists have for other things they would like to view with the camera in relation to the detonation of this charge. And the instrumentation communications engineer, keeping a close eye on those temperature readings, reports that the temperature has apparently begun to stabilize and maybe even move down a bit, so we may be out of the woods on that score. And we have acquisition of signal. We should get a good stable lock-on shortly, which will decrease the noise on the air-to-ground circuit.
Hello, America. You read Houston?
Houston, America.
Yeah, America, loud and clear.
Okay, Houston, America here. The mapper, when we took the image motion from off to on, and then the mapping camera switch from off to on also, I think. Maybe it was standby to on. But anyhow, as soon as we went up to on, they had a barber pole on the talkback. Went back to standby, and just before AOS, or just about AOS there, at 2:15:20, about 2:15:20. Then we got a gray on the talkback with the mapping camera switch to standby. Then we went back through the cycle and it worked okay, so it's working now and it's on. So what I'm saying is it didn't start working until about 2:0.
Okay, Ron, we got that.
Must have been too cold, huh?
Well, look at it. Don't know. America, would you select wide on the high gain and then narrow?
doesn't seem to make any difference. I'll try a reacquisition again. Manual and wide. Auto narrow, doesn't seem to work very good.
Let's try REAC, Ron. You're in a skin reflection zone there. It's probably the problem.
And we just had a call from our instrumentation communications engineer that he saw the charge blow down in the lower left corner of the television screen, and simultaneous with that we're getting a very active response from the seismic experiment. The tracing pens are very active, almost going wild at this point. And the scientists in the back room here also confirm having seen the charge explode. We'll be re-rolling the tapes, rewinding the tape, and playing back a videotape of that detonation.
Gordy, this is the LMP. How do you read?
Jack, you're loud and clear.
Okay, add to that little discussion of the pool bottom cone-shaped craters that I had, I think last rev, that the one place there seems to be some variety in the freshest of those kinds of craters is in Mare Smithy, where the ejecta blanket of many of those kind of craters has some small dark halo craters on them, have small dark halo craters on them. 3 or 4 or half a dozen per crater on occasion. But that seems to be something that I've only seen so far in the Mare Smithy region.
Roger.
They're superimposed on the bright ray or ejecta blanket and our ejecta blanket system of the
of those fresh cone craters.
Okay. America, Houston, I got some words for you to a request for a little visual observation at the landing site area having to do with orange material. If you're ready for about a 5-minute briefing, I'd like to give it to you now so you can get set up.
Okay, go ahead, Grover.
Okay, what we want to do is see if this is triggered off by your observation of orange material last rev, I guess, and possibly earlier. But the idea here is to look for some craters that we've identified on photographs that are in a similar geologic setting to Shorty crater and see if we can see orange material around them. We're trying to determine if the orange material at Shorty is a one-time special occasion or whether possibly it's common to the area and just never been noticed before. And we think you'll be able to determine this visually better than any other way. So if you can get out the orbit charts, the orbit photographs, let's see, the lunar landmark maps for the CSM, and turn to the landing site number 2 of 4 picture. Let me know when you got that, and I'll show you where we think a likely point is to see craters that are similar setting to Shorty and to look for orange material.
Okay, Gordy, we'll do that. I've made a couple passes with the binoculars over the dark mantle around Littrow already and have seen nothing comparable with what's around Sulpicius. But let's have the examples and we'll make a special effort on it.
Okay, have you got the site photo number 2 of 4?
Here it is. Stand by, just one. Tab on it. Which one is that, 204?
No, number 2 of 4 of the site photos.
Oh, 2 of 4. Okay. Okay, we got her.
Okay, you can see the landing site there at down about 4 o'clock, and the
Yes, sir.
7-kilometer crater in on the center line of the page, about a third of the way down from the top. The large, bright crater there is Littrow B, is the name of it.
Got it.
And on the southern half of the ejecta blanket from that crater, there are several dark halo craters, which we think are in a similar structure as Shorty. We think that would be a likely spot to look for orange material. There's Farouk has circled about 4 or 5 that show up, say at 4 o'clock, 7 o'clock, 8 o'clock, and 9 o'clock, out about from the center about crater diameter, in other words, a crater radius beyond the lip, roughly. We suggest that you utilize the best window and your attitude, which you should be maneuvering to now if you if I haven't completely interrupted the flight plan, is in that attitude window, let's see, 1 is the best, and 4 should point up that way also. We suggest you get somebody on the binoculars at 1 and use the same camera setup with the exception of using the 250 millimeter lens if you can, that you're going to be setting up for as per the flight plan for the orbital science photos. If you could put the 250 on there, use KK as shown, and F8, 1/250th and infinity, I'll repeat that when you get to it, for the pictures, if you see anything. What we're looking for is orange material.
Okay, Gordy, we're working on that now, and we'll get KK out.
Okay, we were thinking you might be able to get the guy on the camera in window 4 and the binoculars in window 1.
This is Apollo Control. We're about ready to replay now the videotape showing that second seismic charge detonating. You'll see it down in the lower left corner of the screen. It'll appear as a bright flash with little or no dust visible.
I think maybe you're right about window 4, possibly being a photography window. I get oriented right. I thought you... Oh. There you go. Yeah, it's all set right here. And Gordy, I'm going to try to also shoot, if you'll let me, 2 pictures on KK of that depression, colorful depression we saw near Sulpicius Gallus, if I can see it. Is that okay?
Okay, I'll give you a unilateral go on those 2 frames, and we suggest you use 2 or 3 frames on this area we've been talking about also, in addition to the schedule 28. If we get short of film or something, Farouk says the last part of this orbital science photos, after you get to the end of the run and change to 125th of a second, is kind of marginal for photography anyway.
Right.
Okay, Gordy, you want the pictures whether we think we see orange or not, huh?
That's affirmative.
That's very strange. May have to pass you the camera in a hurry, Neil. I looked, Gordy, the craters we're seeing around Sulpicius that are orange, orangish, are very clearly orange, orangish gray, and the whole, or at least most of the crater is that way. We looked at Shorty today, and Ron says that even the little bit of orange that he saw the other day is not visible, and I'd have to agree with that. The amount of orange we saw on the surface certainly would not be comparable to what we're seeing around Sulpicius Gallus.
Roger.
And in a couple quick scans, previous revs of the area, the dark mantle near Littrow, I did not notice any obvious orange-gray craters.
Okay. Just to make, to be sure we're clear on this, we suggest that area to look for them only as a likely spot, but any evidence of craters with orange material in the whole dark mantle area around Littrow and the edge of tranquility there is worth noting and getting a picture of if you see it.
Okay. Yeah.
I don't think there's anything there. Just take. Yeah, I got a view. Yeah. Okay, 5.6 at a 250, isn't it? No, I don't either. I don't see anything comparable at all. You know, the ones that we've been seeing, the definite orange or the light tan stuff around are pure light ejecta blankets around them, not dark.
Houston, I guess none of us see anything comparable to what is down by Sulpicius. And
Okay.
no obvious color either.
Raj.
Well, they're comparable to Shorty, but they're not comparable to they're not comparable to the ones that we've been seeing. The obvious orange.
No, the craters are comparable to Shorty, as Ron points out, and but the color is not there.
Okay.
Yeah.
We'd like to give you a couple spacecraft chores. I'd like to terminate the charge on battery B and turn H2 tank 1 fans on.
Hand me the camera. H2 tank 1 fans going on, and I'll get that charge in just a second.
Okay, and just a reminder to go back to F4
Are you going to be able to get
at
that?
a 250th when you get ready for the orbital science photos. Also the 80 millimeter lens if you happen to have the 250 on there.
F8.
We're getting a little closer to the terminator. Change to 5.6, Jay. Yeah, I don't know. Maybe not.
See, we're looking down at zero phase.
That's right. It's almost zero phase. Okay.
Crew is taking pictures of the landing site at this time.
Then I changed to F4.
Oh, but you're going to look at the nadir, aren't you?
Yeah, that's right. Are you sure we want the, yeah, that's right, 8-second intervalometer for looking at the nadir with the 80 millimeter, right? Yeah. Okay. Let me take a look down at the that Mare Flora and Dawes. No, that's not Dawes. That's Bessel. Doesn't look like Dawes. Dawes has got a bunch of little depressions. They look like rimless pits in the bottom of it. Bessel doesn't have any of those. It looks like a bunch of debris. There you go, Gene. Hit. Yeah, that's it. Yours is on, I see yours, Gene, it's on up there a little further, isn't it? It's, but all of these are in the, this is not out in the Maury floor of Serrano Taurus. It's on the hills there, the Jemez Mountains. It's just to the west of the Sulpicius Gallus Rill. And it's a elongate feature that runs kind of northwest by southeast. Yeah. No, it's not in the Maury floor at all. It's up there in the edge of the Jemez Mountains. But that was the same type of material that it has the same color difference as the material around the Taquet rills back there. Yeah, see all those bright orange craters right in the Sulpicius Gallus Rill up at the north end of it? Jack calls it an orange-juice gray. I call it an orange-juice tan. No. Jack, did you get the pictures? Good pictures? Because I can take it. See that one? Oh, yeah. See that one on the Maury? Yeah. Yeah. Here, take it. Yep, that's it. Yeah, I can too. Yeah, Gene, yours is out of that. I got a picture of it. Yeah, I know. It's got a, yeah, just in the, wait a minute. Okay, I've got one out in the Maury itself. It's got a strip. And I can't take it in. Yeah, let me get I see one out there. I'll get it. Yeah, I better have, because we're getting close to, matter of fact, I need it just about right now. Okay?
Well, Gordo, we're going to get set up for Ron's orbital science, but that little classic crater, I could see it again with the
Gordo 250?
With the naked eye. I don't think it's the same one that Ron and Jack were talking about, but this is so classic. It's just out of the Maury into the foothills to the right along our orbital track.
And we're starting with Mag 109 for the orbital science on Kilo. And I don't know what the number was before we started taking all of our...
Okay, we copy that. 109 on KK.
Okay. Fortunately. Oh, it wasn't? Okay, there's the old Apennines. Where are we heading for on this, Gordy? Can you give me a clue? South Hemier is a big thing. Stupid thing doesn't work. I got that one. I got that one. I took it. Yeah, I did.
Gordy,
Go ahead.
it's Jack. My impression in that rimless V-shaped depression that had the striking tailless on it, that it also it was a spotted or mottled rim area that has the orangish tan or orangish gray color as the spots, and it looked as if this pass, and I'll try to verify it if we have another opportunity. It looked as if the more red-gray, red-brown-gray, if you will, material was lower in the section within the walls of the depression. This is a very steep wall depression, by the way. It has talus streaming down the sides of it, and the coloration streams in the same direction. It looks as if there may be layers or roughly horizontal zones that have the coloration that we're seeing, which are forming the talus slopes down below them.
Break window I changed to 2.8.
Okay, not till you get on up the line, Ron, and to Lambert.
Oh, okay. Lambert? Okay.
And your pictures are pretty much right along the nadir.
Okay. Lahire Rills. Yeah, we're over Timacurus now, and then Lahire Rills are coming up. Yeah, Lambert's right up there coming up. What's one of the just to the south of Lambert? What is that? Just on the map. Lambert's right by the higher rills. There's one rill that goes right through it almost, and then another one. See, it goes northeast, southwest. Oh, I see. Okay.
Gordy getting a good oblique view of Copernicus on this trip, and some of the dark halo craters that we mapped originally on the north portion of the ejecta blanket, which are similar to Copernicus H, are very clearly darker halo than or have darker blankets around them than the ejecta blanket from Copernicus.
Roger, and Ron should be due to change to 2.8 about now.
And this is a good view of the central peaks, although from some distance, and as Ron and I were discussing earlier, it's not at all clear that in fact that dike does not come true as a so-called dike, as a unit that is clearly defined.
Yeah, looking at it the binocs the last time, and I couldn't really see anything that's really defined as coming on through there.
Okay.
There's still there's very clear distinction between the dark floor material of Copernicus and the hummocky floor material, the dark smooth being in the northwest quadrant.
You know, if Lambert is in that crater, it's sure awful smooth ejecta around that thing. It only goes out about a half a crater diameter, maybe a crater at the crater diameter at some spots at the most, but it's not rough and blocky looking, you know, smooth, smooth undulating.
Ron, your next camera change is at Euler, which you changed to 125th of a second.
Yeah, I think we just crumped. Did.
Got a film?
Yep.
Want that other mag?
But throw Oscar in here, see if it'll work. Need a dark slide. Here. Okay, where's Oscar? Whoops. BHBW. Yes.
We got a good oblique view of the Hortensius domes, and with their nice little central pit craters.
Hey, did we hit the stick or something? Huh? Looks like we're changing attitude. Yeah, I'll be there to put Oscar on there, and I got one picture. And it's empty. Yeah. He's probably right. Those won't come out too good there anyhow. Too close to the terminator for this kind of film.
Yeah, we agree with that. Ron Farouk was mentioning that was kind of, beyond Euler was pretty marginal anyway.
Yeah.
Gordo, that classic crater that I talked about last rev, I picked it up again this rev with the naked eye, and then also looked at it again with the binocs. If Ron was talking about the same crater, and I have my doubts, he got a picture of it, he said. But the interior, I won't say there's a change to black, it's just dark. I'd say it's probably about the size, put it in the right perspective, of Shorty, or just a little bit bigger. The inside is dark. By that I don't mean it's black or anything inside. I just can't really see inside of it. But it's a rust-colored blanket comes out and overlaps on the rims, and then has the classic ejecta. And I'm going to take a shot at trying to get a picture of it next rev or sometime when we're in attitude, because it's too good to miss.
Okay.
Not good.
And Commander, if you can send one of your subordinates over there to terminate the battery charge, we'd appreciate it.
Okay, that's in work.
Seven Bravo. It's coming up just a little bit. Yeah, not much. 1.25.
Okay, Houston, battery charge on B is terminated, and we got 1.25 on 7 Bravo.
Okay, thank you.
Here's November. It may have 3 or 4 pictures left. It's on 160. Finish that one up. Oh, we got Papa for opportunity yet. Yeah, okay.
Houston, you ready for laser altimeter on?
Stand by. America, we're seeing some higher than normal temperatures on fuel cell 1. We'd like you to go to panel 226 and check the fuel cell 1 pump circuit breaker, and also the switch on panel 5. Over.
Well, don't ask me how it happened, but your switch on panel 5 is off. Going to AC1.
Okay, I guess that's the best news that we could have had on that. And we're ready for the laser altimeter.
Okay, hey,
whenever
Gordy.
you get to attitude.
Gordy? Here's one you can explain to me. When I turned that on, well, I guess that I got a sudden drop in H2 flow, and then it went up, overshot a little bit, and now it's steady. I suspect that's what your ECOM friend there will say should happen.
Yeah, that's right, and we see indications that the pump started up.
Okay, that's a good call. I can't, how long have you noticed that, Gordy? You know?
Oh, it's been about 3 minutes, Jack.
Okay, I guess I'm to blame then. Don't know how it happened.
Hey, Houston, America, do we have any more orbital science photos?
Stand by.
I think that was it, but I'm not sure.
Okay, Houston, the laser altimeter's on, and image motion is Barbara +4.
Okay, thank you.
This is Apollo Control at 216 hours 15 minutes. A few minutes ago you heard Capcom Gordon Fullerton query the crew as to whether or not a switch might have been placed in the wrong position on one of the pumps circulating glycol coolant to fuel cell 1. And Jack Schmidt looked at the panel, confirmed that the switch was in fact in the off position, turned it back on, and everything was back to normal with no problem. By way of background, the ECOM, John Aaron, had noticed a slight increase in temperature on fuel cell 1 via the telemetry. After watching it for about 3 or 4 minutes, he asked Capcom to check with the crew to see if the switch controlling the glycol pump was in the off position. And as mentioned, Jack Schmidt confirmed that it was. This pump, as we say, circulates liquid glycol coolant through the fuel cells and cools it in much the same way that water flowing through radiators and around the engine of your automobile cools the automobile engine. The most likely explanation for the switch being in the wrong position that we have here, since it appeared to be a more or less transitory phenomena, was that it was bumped by one of the crewmen moving about the cabin in 0G. The fuel cell temperatures very quickly dropped back to normal once the pump was turned on again. We have about 18 minutes remaining in this pass before we lose radio contact with Apollo 17. We're showing an orbit at this time with a high point, or apocynthion, of 65.2 nautical miles, and a low point, or pericynthion, of 62.2. Among the other statistics, the orbital weight of the CSM at this time is 36,477 pounds, and the orbital period just a tad under 2 hours, 1 hour 59 minutes 17 seconds.
Say, Ron, it's Houston. There's no more scheduled orbital science photos. We can't seem to run down Farouk to see if he has anything up his sleeve. There are a couple passes with black and white coming up, one next rev and then a couple just prior to TEI.
Okay, looks like what we've got left here, as far as I can tell anyhow, is just we've got all of magazine Papa and maybe four or five up on November.
Okay, and we'll come back to you if there's anything we got in mind to schedule on either of those.
Okay, we want to save some for after TEI too, shooting back at the moon.
Roger.
Hey, Gordy, that's TEI 1, not TEI 2 he's talking about. Okay, I see what he said.
Roger. TEI period.
That's right.
These guys can call it what they like, but I know what it's going to be and when.
America, a little human interest stuff here. We just watched the second charge go off. Not just watch, it's been about half hour ago or so. Second charge went off, and we caught it just in the lower left corner of the TV view. It looked like to me it looked like a flash bulb went off. Flash bulb laying on the ground went off. Just a kind of a quick flash. No big shower of dirt or anything that I could tell.
How far away do you expect that one was, Gordy?
That one was 600 meters away. And it was a half-pound charge.
Yeah, you're still pretty far away over that. Yeah, you're still pretty far away over that the terrain that those things are sitting in over there. You're going to probably see something when you look at those at the place by the end of the SEP and back to the east there.
Roger.
Houston, America.
Go ahead.
Do you need the cryo stirred at all today?
Let me see here. Stand by. No? I guess you've been bouncing around there enough. We don't need to stir them.
It won't hurt him, will it?
No.
Okay.
Showing about 115 beats per minute on the CMP.
That call of 115 beats refers to Ron Evans' heart rate, the command module pilot exercising at this time.
Mercury, we'll take auto on the high gain.
Okay, you've got auto.
Okay, America, we're about to LOS, 40 seconds. Everything looks good as it always has. See you next time around.
See you, Gordy. Thanks for keeping an eye on us.
One last frantic reminder to configure the DSE per the flight plan after LOS.
Okay, we'll get it.
And we've had loss of signal with Apollo 17. On this, the 65th revolution will be reacquiring as usual in about 45 minutes. And for the rest of the flight plan up to the cruise sleep period, which begins at about 220 hours, we have a relatively quiet time, very little scheduled in the flight plan, have an eat period. During the next revolution, crew will be operating the panoramic camera in the sim bay. They're scheduled to be in the midst of an exercise period at this time, and we could confirm from the biomedical data on Ron Evans, his heart rate, that he was indeed exercising. Prior to beginning the sleep period, the crew will be going through their film magazines, getting everything ready for an active day of picture taking tomorrow. There will be a lunar surface science briefing at 9:20 a.m. Saturday, December 16, in the main auditorium, Building 1 at MSC. Again, that time is 9:20 a.m. December 16. At 216 hours, 37 minutes, this is Apollo Control, Houston. This is Apollo Control at 217 hours 18 minutes, and we'll be back in radio contact with Apollo 17 in about a minute. On this revolution, the major activities aboard the spacecraft will be the operation of scientific instruments. It's a relatively quiet period of time for the crew. The pan camera will be turned on briefly, just so we can get a look at the telemetry data on that camera. We won't be obtaining any photography with it. The mapping camera will be on for one full revolution, obtaining ground track coverage, supplemented by the laser altimeter data that provides an altitude reference in each photograph. Also, the infrared and ultraviolet spectrometers will be operating, and the crew will be taking a few handheld photographs out the spacecraft windows using the Hasselblad camera. We may have a bit of noisy communications toward the beginning of this pass. We've just gotten acquisition of signal, and we'll be receiving the spacecraft through one of the 85-foot dish antennas rather than the 210 antenna. We do have acquisition of signal now, and appear to have reasonably good signal strength.
Houston, America, looks like we're with you again.
Okay,
In fact, we
America.
know you are. We've been taking the picture just as we came up.
Roger. You're loud and clear.
Okay.
America, Houston, I have 3 one-liners for the flight plan.
Is this the same flight plan we've been working on up here?
I think it is.
Okay, Gordy, go ahead.
Okay, at 21809er, delete mapping camera, retract. At 21830, delete mapping camera, laser altimeter cover, closed. And at 21959, next page. In addition to IR and UV covers open, put in laser altimeter on.
Okay, at 21959, laser altimeter on, and 21830, delete mapping camera, laser altimeter open, and at 21809, delete mapping camera, retract.
Okay, that second one was deleting a cover closed, but I'm sure that's the one you got. Mapping camera, laser altimeter cover closed. And that laser altimeter, we'll just leave her run through the sleep period.
Okay.
That's it, sorry. Smithy may have on the thing. I still want to talk a little bit about these polygonal craters in Smithy. The one right above Rev 62 picture on the thing, there's definitely kind of an undated old depression there with a very smooth Mare floor on the thing with two old craters. and that is definitely a younger flow than whatever made the polygonal crater-like depression right above the Rev 62 number. The thing that bothers me about that is that they almost, look like if you threw a rock in the mud, and made a mud pie, and you get a wave or a ripple going out from there. In other words, you've got a high wave front going out from a circular direction with a slightly sloping up to that wave front. That's on the inner ring on the thing. The outer ring, of course, is a typical type ring that you get from an impact type of an operation. It looked like the rough-looking floors of those ring basins essentially have the same albedo, the same characteristic as the rougher-looking floor in the Mare Smithii itself.
Okay, Ron. We'll take high gain to auto.
Okay, you have it. And I took a picture of that one in Smithy is frame 160 on mag November. And the reason I took the picture is really because on the western edge of the big basin, it looks like there's a small impact crater, but it's only been dished out in the more recent flat, dark gray Mare material. And it looks like when it comes to the edge of the original basin ring, that part is not ejected out at all. So essentially you have a cone-type depression with an impact crater. The material has only been excavated in the newer Mare material.
Okay, I understand that. Say again where that one is.
Well, that's the one above Rev 62, or directly north of the Wright brothers, and the 12 o'clock position from the Wright brothers.
Oh, okay.
You know, Houston, we're just passing over a little polygonal crater that's maybe 15 kilometers in diameter, 15, 20 kilometers in diameter. It's maybe 10 to 15. And down in the basin of it is kind of a polygonal fill. And again, it has a dark greenish black rock that is collected down at the bottom of it, and you also say streaking down the side of it. But I think one of the most significant features about the crater itself is that it has a swirl, and these are honest to goodness, they look like swirls rather than rays. It has a swirl pattern around there that it's radial from that most recent impact.
Roger, Ron. America Houston, we haven't got data right at the moment because we're in a skin reflection zone. Would like you to hold the pan camera to stand by until we call you.
Thank you. Okay. Thanks. It's near, just see Yerkes, come down from Yerkes. Yerkes is the subdued crater up there. Come down from Yerkes, and there's a little one about 10 kilometers in diameter, and then a big one that's about 50, and then there's a bright one. Okay, and then on, yeah, and then right, let's see, kind of northwest of that bright one, about a crater and a half diameter from it, is an orange ringed crater again. Right next to just a bright one there, just about a crater and a half diameter from the bright one. See, it's an orange ring on it, isn't it? That's the one we were talking. I get it, yeah. No, that's right. It's not as classic, but it's another example of an orangish, tannish. Let's see see that bright crater down there? Just about a crater and a half diameter to the north of it. F8 is 250, that ought to be good. And Houston has frame 160 at too.
Okay,
Yeah.
Ron.
Yeah,
And frame just before that, I took of the ridge just on the southern edge of Crisium. The pattern of the massifs in that area were very impressive, but 2 frames just before that.
Okay.
Houston, one other question. I was looking around here in my film, and I got MAG Victor, which is VHBW for the Nikon. And looking through the flight plan, it doesn't look like we're going to be able to use that anytime. I just wonder if we might be able to use it for some of these Terminator photos.
We'll check on the film. We'd like you to go wide for 10 seconds and then back to narrow.
Okay. There's wide. Looks like that did it.
Okay, Ron, the high gain looks good, and on the film, it's your option on that magazine. There's no scheduled usage.
Oh, okay, thank you.
Okay, you want pan camera power on now?
That's firm. We're ready now.
Okay, it's on. What?
Want to get it or I'll get it? Go ahead.
Okay, Mercury, we'll take pan camera power off now.
Okay, it's off.
Landing site? No, optics are up in the air all the time on these sim-based stuff.
Houston, areas in the landing site where we now know there are extensive blocks of the subfloor material, particularly in the walls of the larger craters. I have the impression that those block fields from this altitude give a light bluish gray appearance.
Roger, Jack.
I don't know how far we can extrapolate that in other craters, but we might start trying a little bit.
Roger.
Following that a little bit farther, looking into Dawes, the lower talus slopes of Dawes have about the same hue and are overlain first by a zone that's producing, are several ledges that seem to be producing white talus, and then above that is the or make that very light gray talus, and above that is a tan gray talus slope that carries right up to the rim of Dawes. So there are three distinct major stratigraphic units showing up in the talus slope in Dawes that I can see.
Zach, can you see any holes in the square holes in the floor of Dawes here?
Wait a minute now. I guess I was talking about the crater north east of Dawes. Let me check Dawes for the same sequence.
No, Dawes is the little one down here. That other one's
okay, take it back again. That was Dawes I was talking about.
Yeah. Judy, you using the binocs? Yeah, I talked about Dawes already. But, oh, those aren't holes down in there. Those are just great big blocks that have fallen off of the side of the mountain, side of the... Okay.
Okay, between the tan gray and the very light gray, there may be another thin and possibly intermittent zone of just a plain, apparently gray unit forming in the talus slope. And a crater to the southeast of, southwest, of Dawes. Large crater, I'll get the name in a minute. You see the lower bluish-gray unit, and the next white unit or light gray unit up, but the brown gray unit is not nearly so evident at the top. In fact, I didn't really say I could recognize it there at all. I'll have to check that one though, put a query by it.
Roger.
That's Bethel you're talking about. Okay. Yeah. Is that the Serenity?
No, one back.
Oh, Plinius.
Plinius?
Plinius is that rough-looking one. Yeah.
Yeah, that was Plinius I was talking about.
Oh, yeah? Yeah, the oranges? Yeah.
And the next large, it's not large, not as big as Dawes. It's a reasonable sized crater that to the west, the talus is largely just white debris on the slope of it. But it doesn't look like it penetrated nearly as deep as the other two we talked about.
Menelaus? Takei is the one that's out right underneath us right now. The Menelaus is right on the edge of the Serenitatis Basin before you get to the Jemez Mountains.
Okay, looking at Menelaus, you can see where the the edge of Serenitatis goes through the crater, and the north wall is quite distinctly grayer to, let's say, bluish-gray than the south wall, which is very light gray in the talus. My guess is that it's a very nearly vertical contact at that point.
Roger.
At least that's the way the talus suggests it, but the talus does move vertically. Looking at the depression with all the color streaking in the talus on the walls, I'll say again that the more red looking unit or talus is coming from below the orangish gray material. But it is not a continuous horizon, at least not as so far as the talus indicates. It's local spots that are giving the reddish color.
Okay.
Very good.
Gordy, that particular depression doesn't look like it's an impact-generated depression at all.
Roger.
Yeah, we sure got to look and see if those things still look orange tomorrow. Because yesterday, Stoney looked kind of orange then on the northeast rim of it. It sure doesn't today. Shorty, yeah. You guys will learn the names of all those craters you guys named in here. Oh yeah, I know quite a bunch of them. Hey, yeah, we better end there. Like them. D Caldera is what I call it.
Yeah, Ron's D Caldera. I'm just correlating apparent colors now and hues, and the lighter colored material there is comparable in hue to the subfloor color at the landing site.
Okay, first one's F-32 to 500. Bias Meyer. Yeah, window. Window 5, okay. Got is 55 now on Romeo, Houston. No, not till we come up to Tobias, just before Tobias Meyer. On the other side of Copernicus. Right after 218, okay.
Roger that, Ron. Ron, this is Houston. Do you want any help from me calling the f-stop changes on this P66 run, or you want to do it on board there?
Why don't you give me a little help there? Just kind of reminders. So to F11 about Tobias Meyer, I guess, and then...
Okay, then F8 and the 1/250th at Braille AD.
Yeah, right.
Are you shooting pretty much straight down or out in front on this one?
Let's see, we're pretty much straight down on this one.
Okay, I've got a real-time plot of your longitude, longitude here, so I can call right on longitude.
Oh, okay. I started before Tobias Meyer. goes that's Eratosthenes. Okay.
Hole 1, Jack. It's about time for F11.
Go ahead.
Ron.
Okay, F11 at 500.
That's
Thank you.
affirmative.
Oiler is, lower is blue-gray, and the upper is very light gray in the talus slope up to the rim.
Houston, I could just start to see the peaks of Orla now exposed in a central peak. The tops of them exposed in sunlight, and it looks like there's massive quantities of large boulders on the peaks.
Roger, Gene. Okay, it must be about time for F8 and 1/250th.
F8 at the 250th, okay? That's my little C crater chain down there. Like a cinder cone chain. At between Tobias Meyer and Euler.
Roger. Okay, try F56 and 125th.
5-6 at 125th. Is this the last?
Last setting, right. And you should finish up there at Tobias Mayer W.
Tobias Mayer W.
Okay.
Or a little beyond.
Beyond.
Houston, a mapping camera's coming off.
Roger.
And good. Stand by. At 37.1, mapping camera, stand by.
Okay, Houston, we ended up on frame 80, magazine RR.
Okay, Ron.
Okay, Houston, mapping camera standby now. Image motion is off, and laser altimeter off.
Roger.
Houston, what do you read our glycol evap temp as? I tapped the gauge up here and got a little bit of upward jump in temperature. Just curious how much of a hang-up it was.
Stand by. Okay, we show 66 evap out temp.
That's exactly what it jumped to, okay?
Gordo, I'm interested. How have you been reading me most all day today? I've been on lightweight headset all the time.
I'd say you're fine. Since I've been on, let me check the rest of the day.
Okay. No, it'll be the same all day. You're as good a data point as any. I haven't really tried to make any efforts of talking into the mic or anything. I've just been talking around it, and if you're satisfied, I'm happy.
Okay, sounds good all day. No cutout or anything. No problem.
Okay. Houston, America. The canister is changed.
Okay, Gene.
Yeah, I think if you stand by for some small tugging angles on this one, right within the center of the section.
Okay.
Well, I did get 5 balls that time, but that's not bad.
We'll buy that. Well, the Z-axis there looks pretty good anyway. You're clear to torque.
Okay. We'll target 2-1, I missed 30. Let's go to 21:45.
Okay. America, Houston, request the H2 Tank 2 fan on. Over.
Okay, H2 Tank 2 fan is on.
Okay, and the wastewater dump that you'll start after LOS should take 11 minutes if you want to set your kitchen clock. Also, a reminder, this time after LOS, we go to REAC. Over.
Okay, thank you. We'll do. We'll go to REAC.
Houston, the IR UV covers are closed.
Okie doke.
Yeah?
This is Apollo Control. Apollo 17 now going behind the moon on its 66th revolution out of radio contact. The crew is scheduled to begin an 8-hour sleep period about 2 hours from now. The next revolution will be a rather quiet one. The crew is scheduled to eat prior to completing final checklist items before going to bed. And we do anticipate having a change of shift press briefing, which will start at around 12:15 to 12:30 a.m. in the MSC News Center briefing room. At 218 hours 35 minutes, this is Apollo Control, Houston.